Tim said, I'm Ruben DeLeon, and I'm the Product Support Director at Nautical Control Solutions. And what we do is we specialize in management of the fuel, specifically in the maritime industry. And so today I'm going to be talking specifically about how we use smart instrumentation, more specifically from the Enders and Hauser Coriolis meters, to be able to provide our clients with a fuel efficiency plan and help them in their process. And this is important because due to the recent times that we're having in the maritime industry and the challenges that we're facing, the economic challenges we're facing, we need to find ways to minimize your fuel expenditure and maximize your efficiency. And so with the, like I said, the economic challenges that we're facing, we're seeing a lot of challenges specifically with fuel theft. And so that's one of the issues that we've been trying to address recently with our product. And as I mentioned, fuel is a huge factor in the industry. It's the second highest expenditure in marine fleets. And currently, what we've seen over the past years is we're starting to get from the point where they're using manual measurement methods. So basically, getting into a tank, dipping the tank, and getting the level measurement from that, and then using that to calculate what the vessel consumed over a period of time. So it was a lot of paper logs, a lot of just manual calculations from the crew members on board the vessels. So what we've done over the last several years is we've introduced this measurement technology and being able to measure all the fuel consumption from the vessels, the fuel that goes on and off the vessels, and so account for all that fuel expenditure. So how do we do that? And here's a illustration, a diagram of how the system works. So in order for us to be able to measure the fuel consumption from the vessels, we have to install, what we do is we install Coriolis meters. Oh, not working. So we'll install Coriolis meters on each consumer. So that's each engine, each generator that's on the vessel. And that way we're able to measure the consumption of each engine, each generator. That data gets presented to the crew on board in real time, so they're able to look at the data and see how the vessel is performing, how the consumption numbers are looking. And then additionally, we grab that data and send it over the Iridium satellite network that we have. And that allows us to get the data into our data center and then provide alerts, provide reports, and be able to analyze that data. So once we gather all that data, once we're able to look at the fuel expenditure and where the fuel is being consumed, then we can provide advice and guide the client into how they can optimize their fleet, what kind of changes they can make, or if they maintain what they're doing right now, if that's the right way to go. And so now that we have all that data, now that we've been able to collect all the consumption data using the Coriolis meters, we're able to break that fuel into different modes of operation. So we're able to dig down deeper into the, where the fuel is going, where it's being spent. And so here's an example of some of the modes of operation that a vessel will go. So when it's underway, when it's traveling to its destination, when it's at dock, or when it's in a dynamic position mode, which is automatic positioning system the vessel goes in when it's approaching a platform and it has to stay within a certain radius. And so now we're able to break it down and kind of see where we can provide efficiencies, what we can do with the data that we're collecting. So as I mentioned, we're looking at all the different modes of operation. We're trying to find efficiencies, and so in this particular example here of a fleet that we were analyzing, we can see that we noticed that there was 4 modes that consumed managed overtook the major consumption of the vessels, and so that was underway, DP, standby, and dock, and that accounted for 80% of the fuel expenditure for that particular fleet. So now that we have this information, now that we have the data, now that we're understanding how the fuel is being spent, we can dig deeper into each one of those modes and see what we can do. So in this example, one of the case studies that we did was on the DP, dynamic positioning mode. And in DP, what we noticed when we looked at the data is that there was one vessel in particular that was operating DP in 2 engines instead of 4 engines, which all the other counterparts in the fleet were operating with 4 engines. And so we looked at that and we said, okay, well, let's see how, this is something that can be implemented throughout the rest of the fleet. So we had those conversations with our clients. We looked at, if that was something that could be implemented on other vessels. We also, like I said, make sure that we can implement that on the other vessels, and then looked at how much of a fuel savings that was. And so what we noticed on DP is that whenever the vessels were running 4 engines, they were consuming about 50 gallons per hour more than the other vessels, which is huge. So by reducing down to 2 engines, there's a lot of fuel savings to be had there. And so the client took that information, went and implemented that to the rest of their fleet, and they were able to get huge savings for that. And DP in particular is an important one because it's one that before we had all this data, before we were collecting this data, and it was visible for the client, and it was visible for the operators that are monitoring these vessels. They didn't know how much hours they were spending on DP or when they were using it, and it turns out that a lot of times, just because it's easier, they would go on DP mode and just let the vessel run on DP to be able to maintain their position instead of trying to do other operations outside of the platform area. And so now that's been reduced as well. So there's been a lot of savings just by looking at the data and just seeing where the fuel is being spent. So one of the other modes that we talked about was underway. And so what we do with underway is we basically provide throttle setting optimization for the captain on board the vessel. And so how we do this is we know the speed of the vessel, we know the consumption of the vessel from the meters, and so each vessel will have, this is just an illustration, but some sort of curve like this. And so what we're doing here is we're giving them 2 operational modes that they can get into. And so this is for the captain to use on board based on the real-time data that they're seeing. So if you can get to a certain point, as you can see up here, where you're not gaining any more speed, but you're still consuming more. And so what we have them do with the best speed feature is we basically just have them throttle back a little bit, and that with this reduction, they're able to save some fuel but not lose any speed. So this is important if they have speed requirements, if they're trying to get to an asset at a certain time, they can use this best speed function to be able to reduce that consumption, but still get there at a good time. So now if speed is not that important and you want to save more fuel, what we have is the best economy feature. So what the system is doing here, it's analyzing all the data, all the consumption data, versus the speed, and it's looking at that in real time, and it's giving the captain throttle setting optimizations. So reduce your throttles, let us analyze the data, and then they keep on reducing until they get to that tangential point there where you're getting your maximum fuel savings, and you are losing more speed, but you're getting your maximum fuel savings for a small speed loss that you have. And so this is something that we've noticed over and over again as the crews use this system. They're saving, we've seen up to 10%, 15% on average fuel savings when they use the best economy feature on board. And so here I have an example of a really good captain who really took to the system and utilized it. So what we can see here is down here you have your speed. So this is your speed setting, and then or your speed of the vessel, and then the consumption data, the burn rate that we're seeing from the vessel. So what we see here is these little dips here. Every little dip here was another instance where the captain recognized that he could do better, where the system would tell him that the economy was getting worse and he could do better, and he did. And so what was happening here is there's getting a favorable current more than likely. So the speed was increasing, and the system said, hey, you can do better, reduce your throttles. So they reduced their throttle settings, reduced consumption, and then the speed continued to increase, so they were able to do that again and onward until they got to their destination. And so in this particular case, like I said, this was a great star captain, and he was able to achieve 21.3% fuel reduction just on that trip, just that day. So if your entire fleet is doing that, then there's a lot of fuel savings to be had just in this underway mode, not including the other operational modes that we talked about, like DP. Okay, so the data we're collecting from the Coriolis meters, we're not just able to produce consumption and very accurate consumption readings for the crew members and for the the folks on the ground analyzing the data. What we're also able to do is, because we're measuring the mass, we're measuring the density, the temperature, and then calculating the volume. But one of those items is the density. So in this particular case, this is a tanker, and I don't know if you can see there's the purple line there. This is off the coast of California, and that line right there is the ECA line, the ECA line, the emissions control area. And so when the tankers are on this side of the ECA line, between the ECA line and California, they have to use diesel. And then when they cross the line, they can use heavy fuel oil. So here, because we're collecting the density, we're able to show exactly where they went into heavy fuel oil. And then we start measuring the consumption and allocating the consumption based on what fuel type they were using. So that's the other advantage with the Coriolis meters, is that we can measure anything. We can measure marine grade fuel oil, we can measure LNG even, heavy fuel oil. And so we're able to then allocate how much fuel expenditure they're having while using one fuel and the other, and then also making sure that they're meeting environmental compliance. So this right here is an example of a fuel transfer. So earlier on, I didn't give all the information as I should have. So we're measuring on the vessels the consumption of each engine, but we're also measuring all the fuel that comes on and off using the Coriolis meter as well. And so that allows us to be able to account for the fuel on board by knowing what is loaded and what's offloaded, whether it should have been offloaded or not, and then also what's being consumed. This allows us to also measure the quality of the fuel in a sense. Because we know the density, we can see if, for example, the density goes up to 1, we know that there's probably water in the fuel. If it's a high density, we can also anticipate maybe particulates or something else in the fuel. If we see the density drop down to 0, then we can then we know that they're putting air in the fuel. So that's air, and that's one of the things that when we first started doing this, we noticed a lot of in some parts of the world is that you would see fuel, you would see a good density, and then you would see it drop down to 0. Then you would see the fuel come back up, and then you'll see it drop down back to 0. And so what they were doing is they were basically trying to cheat the system and say that they delivered more fuel than they actually did, because before the Coriolis meters, they were using PD meters, mechanical meters, and they would spin regardless of it was air, fuel, water, whatever it was, the meters would spin and account for something that wasn't there. And so now this has stopped a lot of that fuel, cheating on the fuel delivery to the vessels. And so, like I said, density, and we also have the temperature, so we can look at any changes in the temperature and the density and make sure that we're seeing what we expect to see there. Okay, so in the end, we have a lot of data that we've collected from the systems that we have out there. We have over 400 installations that we've done, and we've analyzed the data from a tremendous amount of vessels, consumers. We have all different types of engines, all different sizes of engines that we've been monitoring, and so we're continuing to store all this data and use that to analyze better ways that we can help our customers find fuel efficiencies and be able to reduce their costs and just overall accountability of fuel. The main point to make here is that we're proven, we've seen it. We've seen up to 10%, average of 10% savings from our customers, and this has come from multiple customers that within 6 months to a year, they're starting to see the return on investment. They're starting to see these fuel savings in their fleets, and this is obviously for some of our larger customers that have multiple vessels, over 25 vessels with the system installed. We're able to provide those savings for them. And I went through that pretty quick, and that's really all I had.